transformer, and we know that single phase transformer is the most important electrical equipment for the whole power system network. So without transformer we cannot imagine to transfer electrical power from farthest way to the near load center or to the near local center. So here we will discuss our chapter 2 transformer, and which is a single phase transformer. Transformer is of two types. Either you can choose for the single phase or you can go for the 3-phase transformer to distribute as well as to transmit electrical power from different end of the circuit to the other end of the circuit. So transformer is the most important equipment, and the contents that we are going to follow in this topic, first is construction of the transformer, second is what is its principle, how the transformer will work, on which principle it works, and that will discuss principle of operation. Then what are the different types of the transformer? There are basically two types of the transformer. One is your high tension or high current transformer, and another one is your low tension or low current transformer. Then what is its EMF equation? How the voltage it will transfer, how the power will transfer from primary side to the secondary side, that we will discuss. That is the EMF equation. Then we will discuss the no load and the on load or full rated operation of the transformer, no load or on load operation. Then the next topic we will discuss phasor diagram on the different type of load, how the transformer will behave, that we will discuss. That is your phasor diagram. Then we will discuss what is its equivalent circuit in the short circuit condition, in the no load operation and in the full load operation. That we will discuss in the equivalent circuit category. Then we will discuss open circuit and short circuit test. To measure the efficiency of the transformer, we will conduct different type of tests, that is your open circuit and short circuit test of the transformer. Then we will discuss the next part is your different types of losses. What are the different types of electrical losses as well as mechanical losses occur in the transformer, that we will discuss. But there is no mechanical losses, that we will discuss. How the mechanical losses is zero in the transformer, that we will discuss in this category. Then we will go to the voltage regulation of the transformer. Since we can step down or step up the voltage in a transformer, so we should know how to calculate the voltage regulation of the transformer. Okay? Then the constructional feature of the 3-phase transformer. In the very first stage, I also discussed there are two types of transformer. One is a single phase and another one is a 3-phase. So what is the constructional feature? How the 3-phase transformer is very much advantageous than single phase transformer, that we will discuss in this category. Then working principle of a 3-phase transformer. Then construction and principal operation of a auto transformer. It has also own advantage. Okay, so we will also discuss what is the real meaning of the auto transformer, how it will work, what is its efficiency, what is its necessity in the power system network, that we will discuss in the construction and principal operation of the auto transformer. Let's go to the next slide, transformer. So as you all see, this is your power transformer. Okay, so 3-phase transformer as well as single phase transformer, both are very necessary to transfer power from one side of the circuit to the other side of the circuit. So this is the transformer. We always come across such type of equipment in our load center, nearby load center. The grid, we already saw this type of equipment, and we know that a layman also can call this is a transformer. So this is the pictorial view of the transformer. Okay. Then what is transformer? So transformer is a static electrical device. What is it? It is a not a converting device. Okay, it is not used for the convert electrical energy or from mechanical energy to electrical energy. It is a transferring device. It is used for the transfer electrical power. It is not a transferring device. So you should remember it is a static. Okay, there is no rotating part. Static means no rotating part. Okay, so it is a static means no rotating part, and it is used to transfer electrical energy from one circuit. Okay, from one circuit to the another circuit. It means from one side to the other side on the principle of mutual induction. Okay, what is the principle? Mutual induction means mutually they share the magnetic flux. Okay, so mutual induction with change in power and without changing frequency. Here frequency is constant. Okay, power can be changed without changing the power and frequency. So what we can change? We can change only voltage and current. Okay, so we can change voltage and current, but we cannot change power and frequency. Am I clear to all of you? So what is its definition? It is a static electrical device used to transfer power from one side to other side without changing frequency with the principle of mutual induction. Okay, so next is construction of the transformer. Okay, so this is the most important part, construction of the transformer. Okay, so here this is the pictorial view of the transformer and it is a construction of the transformer. So if this is the diagram or electrical equivalent circuit diagram of a single phase transformer. So single phase transformer means either you can go for or three phase. So now we will discuss single phase transformer. What we discuss? Single phase transformer. So in single phase transformer, one side is used as an input source. This is your input source, and the other side is considered as your output. Okay, output of the device. Okay, so and the two sides means input and output, they are commonly share the magnetic flux through this iron laminated core. So what is this? This is a laminated core. So if you will try to draw the diagram, this is my laminated iron core. Okay, then this is the input side, number of turn of the winding. Okay, and this is used as an input. That's why we give the electrical source, AC source. Okay, and the other side also we take supply from the core and it is connected with the load. Okay, here this is a load. Clear? So one side you will give current, automatically the other side will get the supply. How? Because both the windings share the common magnetic path. Okay, they share the common magnetic path. So in this common magnetic path you can see here. So when I give some supply at the primary side, there is a number of turn of the winding. This is the number of turn of the winding. So when current is flowing through number of turn of the winding, automatically it establishes a flux phi 1. Okay, established a magnetic flux phi 1. Clear? So in this magnetic flux, since it is an iron part or conducting part, automatically this flux is commonly flow and share with the flux. Okay, and it is 5 m. Am I clear? Or any doubt? If you have doubt, again I can explain. This flux is your mutual flux and noted as phi m. Okay, then this flux again caught by the secondary winding. Then when flux is caught with the winding, according to the Faraday's laws of electromagnetic induction, there is a EMF E2. Okay, there is a EMF, and since there is a EMF and you also connected a load, then the load demand a current I2. Okay, so automatically this side we get the supply. Means power from the primary side is get transferred to the secondary side. Okay, so here this is the working principle of a transformer. Means basically this is the first view how the transformer is working. The winding which is get supplied, or the winding which is connected to the supply side or get supplied from the electrical source, that winding is known as primary winding. Okay, and the other side which is connected with the load, that winding is known as secondary winding. Okay, don't get confused between primary and secondary. Primary means it will get supply or it will act as an input source. Secondary means it will get the output or it will collect current from the input side. That is your secondary side. Otherwise, in electrical technical word, one is your HT side and another one is your LV side. Or you can call it as one is your high voltage side, another one is your low voltage side. Okay, so this is your primary winding and secondary winding. I think this is clear to all. So based on this, now we discuss what are the different construction of a transformer, how the total transformer is working. Okay, next. So different constructional part of a transformer. Okay, so that is, this is the transformer side. Okay, so here the transformer. So this is this line, this one. Okay, this one is the main tank. Okay, main tank where all the windings, the 2 windings or the 3 windings, all the windings are get inside in this tank. Okay, then this one is your conservator. Okay, so this part is your conservator tank. This is for breather, this side. Then this is at the buses, means it will connected with the supply. Okay, these are the terminal point. Clear? Then this is your cooling tubes. For the cooling purpose, we are using cooling tube. Insulating oil, we need a drain of point or drain of pipe. Then this is your tank cover. These are the tank cover. And this small white color, this is considered as your name plate or the specific. Second is your winding, then tank, conservator, breather and additional equipment. So these are